Despite what you see in movies, not all robots have arms and legs and quirky personalities. NASA builds robots that are spacecraft and rovers, many of which help us explore the solar system. But the Spitzer Space Telescope is something else, an astronomy robot that helps us explore the whole universe in infrared light. Launched in 2003, Spitzer was the first astronomical telescope to be sent away from the Earth into its own orbit around the Sun. But since a year for Spitzer is about 8 days longer than an Earth year, it drifts further away from us over time. Radio signals now take over 25 minutes to make the round trip. That's why Spitzer, like any good robot, needs to work independently from its human operators. This is a simulated view of Spitzer as it would look from Earth while its radio dish is pointed at us, transmitting its collected data and receiving new instructions. Spitzer then pivots around, looking at its targets in the sky. This particular sequence from 2016 included the planet Neptune, asteroids and comets, 2 different stars with exoplanets, including the TRAPPIST-1 system, and galaxies both near and at the edge of the observable universe. Impressively, Spitzer works around the clock. Infrared telescopes on the ground require darkness and clear skies, and even Hubble can have limits on how much of its orbit around the Earth can be spent collecting data. Spitzer is free to shift from one target to the next, or just sit and monitor a single spot of sky for days or weeks. You might notice a pattern forming out of its targets. They all fall within a circular band of sky. Spitzer must constantly keep its sunshield and solar panels facing the sun to stay cooled down and powered up, so it can only pivot around its axis. Its only real limits are how much data it can store and how long it takes to transmit that data to Earth. During this run, Spitzer had been downlinking data and getting new instructions about once a day. But over 90% of its time is devoted to efficiently studying the universe. What we've seen here covers just 6 days, out of over 5,000 since launch. While the astronomers who constantly identify and schedule new science targets occasionally get to take vacations, this workaholic astronomy robot is expected to keep operating non-stop through the commissioning of NASA's next infrared astronomy robot, the James Webb Space Telescope, scheduled for launch in 2018.